Welcome back to EEforEveryone. I am holding in my hands the boards for our prototype inverter. On the bench are the parts that are going to go on this board. It looks great. Let me pull one out here for you. Minimum order quantity of 5, so you've got a couple spares. And it's got room for the heat sinks, the inductors, the output filter. It's here, it's time. Let's build this board. Without further ado, let's start this journey. So one thing I wanted to say that I didn't before is I already checked this board for shorts between the different power and ground planes. Just to make sure there aren't any gross manufacturing defects. That way I know in the future if there's any shorts, I'll know that those were from the soldering process. But without further delay, let's crack open this wonderful box of goodies that I got off DigiKey. Packing slip. It's unusual. Got it in like 2 bundles. Alright, so heatsink. 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 I think these are our heatsinks. I don't think I got that many though. This is quantity 7. Quantity 5? What the heck? I only bought 5 heatsinks. How many heatsinks did they send me? Oh, were each one of those a pack of 5? Oh, I've got to read more carefully. Well, I've got enough TO220 heatsinks. Oh, I thought that was priced per each. That was priced per 5. Well, got some extra heatsinks. They weren't terribly expensive. I think it was like $1.50 for 5 of these. All right. Fits exactly within the keep out area, so hey, no complaints there. Dimensionally accurate heat sinks. What more could you ask for? Oh, I know what else I could ask for. Isolated gate pads, because those are electrically connected, I believe. I might need to make a run to the shop before I can proper finish this. There we go. So we've got 1, 2, 3, 4, 5 different capacitors. We've got 1, 2, 3, 4, 5, 6, 7, 8 different resistive elements. Oops. 10 different resistive elements. Some connectors go around the board. And certainly not least, we've got our active components and then our power components. So I'm not sure exactly how I prefer to put this board together yet. In general, I'd work from complex and difficult to less complex and easier. But in this case, I'm so confident I can solder it all, I wouldn't call any of it really complex, which, I mean, it makes it a lot easier to organize your parts because they're all pretty equal, but it makes it a little harder since they're all equal. So in this case, I think I'll just do the R's first, all the resistive elements. R's and C's, just because they're the smallest. Then I'll circle around to the ICs and bring her home with the large power component. There we go. She's in there solid. Holy cow, it feels real. It feels real. We're going to build an inverter. We're going to build an inverter. Alright, let's crack open the design files. Let's get this bomb open. Let's do it. This is such an exciting day. It has been a long time in the making, this project. A long time in the making. And we're gonna fire it up, grab this scope, and take a look at how it works. Got this printed off in an order that doesn't look completely ridiculous. Nothing left to do. Let's do it. I hope that you enjoyed this video. I can't wait for the next parts of this series where we're going to power up our board and see if it works. I can't wait. It's going to be so much fun. All the banana plugs are there. We've got our little test leads to hook it up to the power supply. It's going to be great. So stay tuned for the next parts. We're going to exercise this, take a look at some control schemes, see what happens when we give it dynamic loads, tune a control loop. It's going to be good. Don't miss it. Make sure you subscribe. Catch you in the next one.